Some tips to solve or to work on your 6.7 through 6.8 review. So, some rules to solve. The big idea here is that we're going to be solving polynomials. That's what 6.7 and 6.8 we did. We solved and found all the zeros and roots of these polynomials. Now, we have some rules if the degree is 2 that we've been working with. We have rules if they have a degree of 3 and a degree of 4, but sometimes they don't fall under one of these rules, and we have to resort to 6.8 and what we learned to solve the polynomial. Okay? So let's talk about the rules that we do know to solve a polynomial with degree 2. First off, what is it called if the degree is 2? It's what? A quadratic. Someone said it. Okay, so it's usually in the form of ax squared plus bx plus c equals 0. Okay, so what are some ways that we have resorted to solving these quadratics? Quadratic formula is one of them. Oh, that's hard to see. So that means we should probably know the quadratic formula. What is the quadratic formula? A couple people were saying it. Good. Okay, x equals negative e plus minus square root b squared minus 4ac all over 2a. Okay, so quadratic formula, that's one way. What's another way? What's another way? You could graph, but it's going to take a while. So I'm going to write in parentheses, try to avoid. The other problem with graphing is if you waste all that time graphing and it falls between like 0 and 1, the only thing you can tell me is x is between 0 and 1, and then you'd have to resort to quadratic formula to find exactly where between 0 and 1 it falls. So graphing is something that we try to avoid if we can. Okay, what's another way we can solve a quadratic? Factoring. If it's factorable, go this route. Because that's usually your quickest method, if possible. Okay, if it's possible, that's usually your quickest method. Okay, there's one more, and we often forget about it. Get x alone. Or solve for x. This will only work if there's not an x term, if there's only an x squared term. So for example, if you had x squared plus 7 equals 14 or whatever, see how there's no x term in this? I can get x alone by subtracting what else is with it, then square rooting both sides. That will allow me to get x alone. Okay? Those are the 4 possibilities. Like I said, try to avoid graphing, so I'm actually going to cross this one out because this is not one that we've used during this unit because it doesn't allow for accuracy. Okay, so that one we avoid altogether. Meaning we have these 3 methods that will always work when it comes to quadratics. Okay, if it's possible, we can factor. Sometimes it's not possible. Getting x alone only works in some scenarios. The quadratic formula is always your go-to if these 2 don't work. These 2 are going to be faster if it's possible than quadratic formula. Yes?
On the quiz, can you do it any way you want?
You can do it any way you want as long as it's a possibility. Factoring is not always going to work. So if you can't factor it, then you're going to have to resort to quadratic formula. You will have to know how to do quadratic formula because I will promise you that somewhere on that quiz there'll be something not factorable that you'll have to use quadratic formula on. Also, you run the risk of running out of time if you have to resort to quadratic formula every single time. If you were given a bunch of problems like this, it's very easy to just solve them. Does that make sense?
Yeah.
So you want to make sure you know the best methods. All right, let's talk about degree 3. Degree 3, which is called, does anyone know what third degree polynomials are called? Cubic. Now we specifically talked about ways to factor cubics. And that's really the only possibility that we will be able to actually solve these is by factoring. Okay? If it doesn't follow one of these rules that we already know, then we're going to have to resort to our 6.8 stuff and say, okay, what's that constant term? What are the possibilities of zeros? Make my whole possibilities. Okay, what's an actual zero? Okay, let's factor out the factor from that. Okay, so we'll have to resort to 6.8 if it is a third degree and it doesn't match one of our ways to factor. So, when it comes to factoring, we have the sum of cubes. We have the difference of cubes. And we always can go for a GCF, which is your greatest common factor. So that also works up here when you're factoring. There's lots of ways to factor quadratics, so I didn't even list those ones. So what do these look like then? If it's a sum of cubes, we have a number cubed plus a number cubed. And it factors into a binomial times a trinomial. How does this factor? A plus B. And then this one is A squared minus A times B plus B squared. Okay. If it's the difference, it's very similar, but instead of adding two perfect cubic numbers, we have subtraction of two cubic numbers. When we factor it, we still have a binomial than a trinomial. The only thing that changes is where those signs are at. So they both only have one subtraction sign. This subtraction sign is here. Where's the one subtraction sign in this one? In the binomial, in the first one. So we know those are both positives. Now the letters are still all in the same spot, or the variables, I should say. A minus B, this is A squared, this is A times B, and this is B squared. GCF, just look and see if there's a common term. But that's the only other way we really know how to factor when it comes to cubic or third degree polynomials. All right. If we move on to a degree of 4, this is actually a quartic. And we only learned one form of factoring for this one. And the way that we learned this type of factoring is if you have something x to the fourth plus something x squared plus something, where you'd have a number, and a number. And we learned that if this was the case, do we remember what we use in order to better factor this? U is equal to x squared, and we use U substitution. And then this becomes a number U squared plus a number U plus a number, and then what we do is we just apply our rules for quadratics because this is now a quadratic. And then that'll allow you to solve for u, and in the end you switch u back to x. And once you have x, then you keep solving to figure out the values of x, and that's how you can solve when you have a fourth degree. Also, technically, you can do GCF with a fourth degree also. So we could put that one on there too, because GCF always works. Okay. So if you're looking at number on the review, you'll notice 1, 2, 3, and 4 all say to state the number of roots and then find each root. Okay? If it's not set up like 6.8, then it means that there's a different way to solve it, an easier method. Okay? Meaning that here you'll be able to find the number of roots. There's some way to factor it then. Or one of these methods that we just talked about to solve it. Same with number 2, same with number 3, same with number 4. Now the key thing is factoring is a big idea. But before we can factor, remember the point of factoring is that you can set each of your factors equal to 0. And then it becomes easier to solve. This is not set equal to 0, so you're not going to be able to factor the left side and say, oh, each of those factors equals 0. You have to first set your polynomial equal to 0 before you can work out factoring it. Because once you have a bunch of factors equal to 0, that's when you can say, oh, everything multiplies to 0. Something in here has to be 0. Either this equals 0, that equals 0, this equals 0, and then you can go about it. So to start these problems, you have to make sure they're set equal to 0. If you look at the back of that page, these are the ones where they tell you the roots. Okay? Sometimes you have to add in an additional root. When do you have to add in an additional root? When they give you an I one. So like here, they told you 6i was a root. What is the root we have to also add in? Negative 6i. So make sure you add in when you have to. Okay? 7 and 8, you might have to also add one in. All right. Also remember that your final answer is not going to have fractions in it, so get rid of the fractions. So when you set x equals to 2/3, get rid of the fractions when you're setting it equal to 0 to find that factor. Numbers 9 and 10, now this is like in 6.8. You're finding all possible zeros. You're finding all possible zeros, so that's going to be a long list. Find an actual 0. You're going to be doing some synthetic division here, writing it in factored form, and then finding all your solutions. Okay, and there's 2 more on the back also. So you guys have the entire time today to work.